Okay, today's going to be a kind of a simple, video. We're just going to review separate axis theorem and kind of expand on it in the game that we have. So, separate axis theorem, let's open this up, basically states, say we have two objects that may or may not be in a collision. If we draw an imaginary line in whatever direction, and we project all the vectors or the points on the shapes that we have onto that line. And then we say if those two projections on that line overlap, then there's a collision. Or then we don't know if there's a collision or not. And if we do that for all degrees, then we can say, hey, there's no collision. But if one side or one angle or one specific orientation of the line says, hey, there is a spot where there is an overlap, then we can say, hey, there is no collision. This is kind of, so say we have here, let's say let's reload this beginning. So first we have the projection of these vectors, points on, or the points on the shape onto this line, this gray line that we have. And then we take that length, or we take all those points, and we basically say, hey, this is the span at which this shape has. This is kind of the range of coordinates, basically, on this line. If those two ranges overlap, then we say, hey, go to the next degree. If they don't overlap, that means that you can draw an imaginary line between the two, orthogonal or 90 degrees to your imaginary line. And if you can draw a line between two objects, that means they don't overlap. So in this example, what you can see is if you rotate, the line kind of generates because it's saying, hey, those two shapes don't overlap. So this means that they're not in collision with our algorithm. But if we move it over to like 350 and then we rotate around, no matter what degree we do, there is overlap. Now this is the case for the object or for the shapes we've done so far, but it's not always the case. We can do that and that. Now with this shape, obviously, if we go around, there's no line that we can draw that separates the two objects. But as you can see, they're no way in collision. So this is kind of why we have to specifically avoid these shapes, specifically concave shapes. Because concave shapes, they indent, and we can't account for that indent when we're projecting onto the line. The way we kind of get around this, if this is something you want to do, is you can separate to two separate shapes, and we can go through that as well. So say, for example, we have our concave polygon game object, and that's that we have one, two. Let's say we remove these two, and instead we do a new vector 2 where it is the -1, 0. Oh, and then I need that. Wait, this, that. Trying to spell. Yep. Okay. We basically had the exact same thing. We just split that in half. We basically separated the shape into two distinct triangles, or two distinct shapes now. And specifically two concave shapes. And now if we rotate, we will be able to see the line, And we say, hey, okay, now there's no collision. So when we split them, we can actually generate, we can split concave shapes into convex shapes and then reapply the same theorem. There's a couple ways to do this, but if you want to do this, again, I would ask Rix about how to do it. But this is just one kind of sample of why concave shapes don't work. And again, kind of re-explaining how we determine if two shapes are colliding or not. What we do, let's uncomment this, is when we take that projection, when we project, we look at these shadows, quote unquote, and we see if they overlap. That's simply saying if the left max is less than the right minimum, then which means that this right side doesn't go to this left shape's or right shape's minimum. That means we can draw a line between them, which means there's no collision. So let's expand our current game to add collisions. So if we go into here, currently we have, we don't need that. Let's do this. Oh, what's the issue? So it's a triangle game object, triangle controller, rigid body, I think that's right. And if this works then, okay. One thing to note, so in class, in vector to game object, we change it to do instance of instead of constructor.name. And we'll kind of expand on the do something very similar, hopefully, later in this video. But say now we look at it, now we have all these game objects that spawn. Let's do a simple survival. So let's make it so that we can destroy these blue triangles. Well, what I would do is let's put this inside of the laser controller. And then we also want to use your collider.js. So what things will need a collider? What game object specifically will need a collider? Well, I would say the triangle class would. And I would also say the bullet or lasers would. So those two need a collider and basically say, hey, collisions matter on this. Now, if we go into our triangle controller, and let's now kind of, first what we have to do is we have to get the game objects of all the triangles. This is now going to introduce inside of our engine.js, scene.js. This is where we can get the list of game objects. But that gives us everything. What we want to do is we want to get, just like how in GameObject.js we have a get component. What we want to do is we want to do a get game object. And we also want to get game objects. And all this simply does is it's very similar to the get component. And all it does is this dot GameObjects dot find, and then we can say GameObject into GameObject of type. So we'll kind of explain how this works later, but what this does is, given a list of game objects, give me the first instance of game object called type. And type can be any input you want. Instead of find, what we want now is for get game objects of type, we want to do filter. And what this will do is say, hey, if it is this instance of type, add it to this array, and then we'll return this array. So, for example, let's kind of experiment with this. Inside of, let's do our laser controller. Let's say engine.current scene.getGameObject, and let's say, let's do a rectangle game object, and we want to console.log this to see if it works. So now when we run, let's see, this dot add component is not a function in triangle game object. Did I just misspell that? Yep. And then saying this dot add component is not a function in laser. Yep. Okay. Now we're getting this rectangle game object. Which, what is our rectangle game object is our player. So let's actually adjust that to okay. So now we have our player, and what we're getting is this rectangle game objects by calling in our triangle controller. No, not our triangle, our laser controller. We're logging the get game object. Now if we change this to get game objects, now it returns a list of that one game object. So now instead of doing rectangle, let's do triangle game object. Now we have all the list of the triangle game objects. And we have the stuff like the components that we can find and mark for delete. So now what we can do is we could say, hey, for enemy of engine dot. For enemy of our engine.current.getGameObject, so triangle game object. So now we're looping through all the enemy triangle game objects. Let's just now console.log enemy. And now we're printing all the triangle game objects. So now what we can do is we could say, hey, if collision, what would it be called? Collisions.inCollision. Collision. Now we call our two objects, which would be this dot game object and enemy. Say console, and then let's do enemy dot destroy. Oh, what is this in my laser? lasers. There. Why? That's fun. Okay, let's look at source and kind of let's go and see what's happening. There in class, components, laser, that's marked there, that's there. That enemy, so now we loop through. An enemy is, I don't care about that. Okay. Now we loop through enemy. So now we do enemy.destroy. So it's saying that the laser game object is already in collision with the enemy. Let's see if it destroys any of them in here. Nope, it doesn't. Okay, so it destroyed it somewhere though. So now we can kind of so it does that. You can step out of that. Okay, so now let's continue looping through this. Does enemy have mark for destroy? Okay, so now we move through here. Now we update. Okay, so it looks like it's marking them for destroy regardless, so if they're in collision. Let's double check. Let us do this instead. Instead of doing enemy.destroy, let's do console.log destroy. So we already have 1,000 destroys. So what's happening is that no matter what, it's saying, hey, it's in collision. Okay. Might just be something wrong with my collision.js. So let's run this just to check if my collisions work. It says 0, 1, 0, 2, 0, 3, yeah. So there's something wrong with my collisions. Let's see. Let's go back to our collision.js and let me look at what's wrong with my collision. So all I'm doing is pulling a GitHub on my other monitor so that I can kind of see where I could have went wrong. So we get the points, and then we scale dot plus the transform dot position, and then first point, second point equals I plus 1 remainder world points dot length. And then then we do first points minus the second points to get the vector. And then we get the orthogonal of it. Then for each we do point dot line if math dot let's just do this, if math dot max of shadow A, or math dot min is greater than math dot max of shadow B, or math dot, let us just copy, so it's math dot max of math dot min max math dot min of the B, and then we just need to put these signs. And now if we go back here, does it still say that? So it says that everyone's still in collision with each other. Okay. This shouldn't matter, so we can kind of do. Yep, okay. Okay, I'm back. So I just retranscribed the collisions.js in the GitHub repo to get that working. Don't really know what was wrong with mine, but we will kind of see. What's this? I might go back and take a look at that later. But now if we check our games collisions, it works. So now that's good. What we can do is we can go into our triangle laser component. Okay, since we have this detail, let's kind of go over everything again. So on our laser controller, what we do is we loop through the engine.currency.getGameObjects. And getGameObjects is something similar to getComponent, but we have two options. We either return, we can do getGameObject, which returns a specific game object, or getGameObjects, which returns the list of all the game objects of that type. And what we do is in our triangle controller.js, we get not triangle controller, in our laser controller, we go and we get all the game objects of our triangle.gameObject, And what we will do is then we will just call destroy on the enemy to destroy the enemy. So something very simple, and you see that now they are destroyed once they overlap. Yep, so right now it is like that. Let's do a few adjustments. So I don't want any triangle game objects to spawn. All I want are enemy spawners. And then I'm going to do the same thing for enemy spawner. What I'm going to do is I will pretty much copy and paste this exact same thing, but now instead of triangle game objects, I will do, where is it? Enemy spawner game object. So now I can delete those as well now. And then say, for example, I want, let's adjust our scene a little bit to make it look more like a game. So let's do 500, and then let's do like 800, and let's do 50, and then 50, 100, 300, 500, 350. Okay. Instead of 900, let's change that to 850. 800. Okay. So now we can do a game where there's these spawners and we have to kill the spawners. So basically what I just did was I changed the scene up a little bit to make it more like a game to spawn stuff on the top, and then to destroy them by hovering over where they're at. Let's kind of change this up a little bit, and let's do some more, and let's make it more, let's do like 800, 900, 700, 1000. So now we have a bunch of these, and now what we can do is we can do a game where we have to destroy all of them in order to win. And let's adjust the enemy spawn controller to where they can spawn as much as they want. And then let's have it so where now we can die, and it's going to be very, very simple to where it's out of update. So we could pretty much do this, copy and paste in our side of our update at the bottom for that enemy.triangle game objects, but then we do this .game object .destroy. So all I did was copy and paste it because we're just trying to loop through our enemies. And if we are in collision, if this current game object's in collision, then we just destroy this game object. So let's reload just to make sure. And then if I could hit, I am now destroyed. So now we need to switch scenes and say, hey, you lose. Let's make a death scene. And what we do is we just do class death scene extends scene. I don't know. Let's do this actually inside of here. Let's just have a we don't have a text component yet. So that might be something we could do. But let's just have it as a blank scene, and then let's say that when we're destroyed, let's just do this. Engine.current scene equals new death scene. And let's just do that, and then make sure inside of our HTML, inside of our scene, we have death scene. There's a couple things we may want to do with drawing stuff, so I'm trying to avoid that. So like here, nope. Okay. Let's see what's happening. Engine.current scene equals new death scene. Let us reload to make sure that. Yep. All right. So now when we do it, so now if we die, it just goes to a new screen, new scene. There's a couple things that we want to do to make it a little bit more like Unity, but generally that's kind of the way you switch scenes. And then you could have like a button, and then if they press enter, then they can replay. So let's just do this. That actually means it's pretty simple. Let's say death scene or death controller.js. Class death controller extends game or extends component. It's not constructor, it is start. We need to be start it. We need to also be able to update. Also need to, and we could say if and then similar, you could always reference like this, where we do like if input doc keys down includes arrows, but let's do space now instead. We do engine.current scene equals new main scene. And what we need is we need a death game object.js, where this is class death game object extends game object, where then we have a constructor super. Remember that you can always label it as like a death game object. Then with this dot add component new death controller. And what we need to do is make sure we add it. So inside of our here, we can do our HTML file. We could do death game object and then death controller. So let's see if this works. Oh, in our death game object, there's a typo. Let's die. Now if we click space, let's see if that's working by doing this. Components, death controller, there. And let us move this over again to try and debug it. Okay. So if it's not liking space, even though it's recognizing that I'm clicking space, there's an issue. Does this even work? Let's see. did I add deathController.js, deathGameObject? It's because in the scene I never added it. This dot add GameObject new deathGameObject. Oh, and I need to make sure I put this in the constructor. Then call super and then add that there. And now what we can do is when we die, break it. Oh, yep, wrong one. It is instantiate. So now we have now we've unlocked that, and now if we click space, let's restart that and let's try again. So now if we go down, click space, and now yep, okay. So now when we die, we click space, and then we can kind of start the game again from scratch. This was a lot, so let's review what I kind of did to update the game. There are some errors, so I kind of let's kind of review everything. So I did some basic stuff in the scene, in our main scene, where I just added more enemy spawn game objects, and then moved my rectangle game object down to be more like a space shooter shooting up, because that's where our bullets are going towards. Inside of our laser game object, our laser controller, what we do is we loop through our current scene, and we call it getGameObjects, which gives us a list of all the game objects of a specific type, and that is in our scene.js file. So it'll give us an array of all the triangle game objects, and all we have to do is inside we say, hey, if we call collisions.inCollision on the current game object the laser is attached to an enemy, we can destroy the enemy. We also do that for enemy spawners as well. And then we went into our rectangle controller, and we did pretty much the same thing with the enemy triangle game objects. And we say, hey, if they're overlapping or if they're in collision, then we destroy our current game object. Then we added a new scene. This is the first time we're doing it, so what we can do, at least right now temporarily, is we call engine.currentScene, and we set it equal to the new death scene. This now takes us to this death scene, where we have the death game object, which simply has the death controller, which simply has, hey, if we input space, we go back to the main scene. Now this gives us the infinite loop that we want, where you can kill stuff, you can then die, and then you can try again, kind of creating now a fully functional game. One very next thing we could do is we could keep track of a score, or something of the sorts like that, but I'll leave that up for next time. So today we kind of added, today we reviewed the separate axis theorem, kind of explained why concave shapes don't work, but convex shapes do, and we explained how to determine if the shadows of the shapes are overlapping. We expand the game to include some new stuff like switching scenes, doing collisions, and adding the findGameObjects and findGameObject methods in order to actually get them to do some collision stuff.